Hello everybody, this is Michaela Mooney doing Vertex Edge 9 discussion assignment, and this is the last discussion assignment for our Vertex Edge graphs unit, and it is bittersweet because I'm excited to move on, but I've also really enjoyed this unit. So let's just jump right in. And today we are going to be using the recursive packing algorithm to pack a knapsack or backpack, you could call it whichever one you would like, with these items right here. And we can use each item as many times as we want. So our knapsack has a capacity of 10 pounds. It can only hold 10 pounds worth of things. But we could fill it with, so A weighs 1 pound. So we could fill it with 10 A things that are 1 pound each, or we could fill it with 2 C's, which would be 8, and then 2 A's, which would be 10, or we could fill it with 3 B's at 3 pounds apiece, so that would be 9, and then 1 A. The combinations are endless, but filling it to capacity isn't the only thing we have to worry about. We also want, see, each of these has a monetary value. We want the highest value. We want the combination that A fills our knapsack, but B will be of the most value to us, has the highest dollar amount. So how do we do that? We use the recursive packing algorithm. And basically, what we're going to do, make a chart that lists capacities from 0 up through the capacity of the knapsack, which I have already done right here. So we start at 0 capacity, and then we end at our 10 capacity. So the capacities here are in pounds. I didn't label that, but we'll just remember that. And then after that, we're going to start with 0, 1, 2, 3. So we're starting here, and then we're moving up, and we're going to determine the optimal knapsack of each capacity until we reach the capacity of the original knapsack. So we are basically going to be finding the optimal combinations of contents for each of these. Like hypothetically, if our knapsack had a 0 capacity, or if it had a 1 capacity or a 2 capacity, we're going to find the optimal combinations for each of those until we get to the actual capacity of our knapsack. Because if we have the optimal combinations for each of these, then we can use those to help us find our 10-pound knapsack's best optimal combination of our little blocks here. That will give us the highest value. So, how do we do that? I will show you. If we're starting with a capacity of 0, that means we can't add anything to our knapsack. So the contents are going to be empty, and our value is going to be nothing because we can't put anything in a knapsack that can't hold anything. So easy peasy. Knocked the first one out of the park. But now, if our hypothetical knapsack can hold 1 pound, that means we could fit just this in that would be the optimal content, because we can't fit B because that's too heavy. We can't fit C because that's too heavy. So we could fit, this is the method that we're going to go. We go through each letter. So we would start with A, and if our knapsack can hold 1 pound and we add 1 pound, that means we would, oh, sorry, I need my pen. That means we would add the optimal capacity of 0 pounds, because that's how much we would have left over, right? And then 0 pounds has nothing added to it, so it would just be A. and that equals $2. That might be a little confusing at first, but it's going to make more sense as we go on. 0 is kind of complicated because there's nothing in it, so it doesn't really show you how using the previous ones helps you find the optimal capacity for the next ones. But bear with me, I promise it's going to make more sense as we go along. So for our first one, the optimal capacity is going to have A in it, because A weighs 1 pound, our capacity is 1 pound. There's no pounds left over, and that is going to be worth $2. So that one's pretty easy because there was only one correct answer. There was no other combinations that we could possibly have. But let's look at number 2. So if we have a capacity of 2, we're going to start with A. We're always going to go in alphabetical order, like ABC, just so it's easier for us to keep track. A weighs 1 pound, so if we add 1 pound to our 2-pound knapsack, that means we are going to have 1 pound left over to fill. And we want to look at our 1 pound optimal capacity to fill that extra 1 pound. And what is that? Oh, look, it's on our list. It is A, worth $2. So that means we're going to add our original A plus the optimal capacity for 1 pound, which is also A. And then we're going to add those two values together. So 2 plus 2 equals $4. And next on our list would be B. We would do B next, but B weighs 3 pounds and we only have 2 pounds, so we can't use B yet. So that means our only option is this first one right here, A plus A at $4. So the optimal capacity for 2 pounds is going to be A plus A, and that is valued at $4. So now moving on to capacity number 3, we start with A, remember, because we're going alphabetical order. So A plus, if we have 3 pound capacity and we add A, which is 1 pound, that means we have 2 pounds left over. And so we are going to look at our 2 pound optimal capacity for what to fill that extra 2 pounds with. And it says we are going to fill it with 2 more A's, and that's going to give us our highest value. So we do our original A plus A plus A, and remember those 2 A's came from right here, the 2 pound optimal capacity. And those 2 A's are worth $4, and we're adding an extra A, which is worth $2. So our total is going to be $8. And now we can actually look at B, because our optimal capacity is 3 pounds, or the capacity of our knapsack is 3 pounds. And B weighs 3 pounds. So if we add 3 pounds to 3 pounds, then we have 0 pounds left over. And we aren't going to add anything else because 0 pounds is empty, so there's nothing to add. And so we are just left with B, which is worth $8. And next we would do C, but C is over capacity, so we can't do it. Now, both of these options, both of these combinations have the same value. They're both worth $8. That means we could choose either of them as our optimal capacity contents. I am going to choose B just because it only has one letter, and that way I don't have to keep rewriting A plus A plus A plus A plus A plus A later on. But really, you could choose either one, whichever one you feel like. I'm just choosing B because it's less writing for me to do. So 3 is done. we are moving on up to number 4. And remember, we always start with A because we're always going in alphabetical order to make things easier for us. So that way we make sure we hit every single combination we could have. A is 1 pound. We have 4 pound capacity. So if we add 1 pound, that means we have 3 pounds left. And so we look at the optimal capacity for the 3 pound, which we just found last time is B. So we're adding 3 pounds. And that means we are doing our original A plus B. And that equals $8 plus $2 is $10. And then after A, we do B. B weighs 3 pounds. Adding 3 pounds to our 4 pound capacity means we have 1 pound left to fill. So we take a look at what our optimal combination for a 1 pound capacity would be, and that would be A, which is worth $2. So we do our original B plus A, and that is $8 plus $2, which is $10. And guess what? We can finally use C because C weighs 4 pounds. Our capacity is 4 pounds. So that means we have 0 pounds left over. So we are going to do our original C plus nothing because a 0 capacity has nothing in it. And that is worth $11. And we are looking for the combination of the highest value because that's going to be the optimal capacity filler. And that happens to be just C right here because 4 pounds fills 4 pounds and 11 is bigger than 10. And notice again, these two have the same value, and that's just because they're both A and B just flipped around. So if either of these were the highest, if these two were the highest value, we could have picked either one because they're the same thing. But our highest value is C, and that is worth $11. And now we can move on to our next capacity, which is capacity 5. Starting with A, which is 1 pound, 5 minus 1 means we have 4 pounds left. So we look at what the optimal capacity contents for 4 pounds would be, which we just found out is C. So we do our original A plus C, and C is $11, A is $2. So that combination has a value of 13. After A, we look at B. B weighs 3 pounds. Our 5 count, if we fill 3 out of our 5 pound capacity, we have 2 pounds left over. And to fill that 2 pounds, we want to look for the optimal combination with the highest value, which we already found is A plus A, and that's worth $4. So we do our original B plus A plus A. And then $4 plus $8 is $12. And then we can also do C. C weighs 4 pounds. So if we fill 4 out of our 5 pound capacity, we have 1 pound left over. And if we look at the optimal combination for 1 pound, it's just A. So we do our original C plus A, and C is $11, A is $2, so that is a value of 13. So the two highest values are this guy and this guy, but check it out, they are both A and C, just in a different order, so we can use either one. They're the same exact thing, so we can put A plus C at a $13 value, and we have successfully done number 5. Moving on to number 6, we are looking at A again. A is 1 pound. If we fill 1 out of our 6 pounds, we have 5 pounds left. And we look at our 5 pound optimal capacity, which is A plus C. and that's worth $13. So we do our original A plus C, and we do $13 plus $2 is $15. Next, we look at B. B weighs 3 pounds, so if we fill 3 out of our 6 pounds, we have 3 pounds left over. And that means we're going to look at the optimal capacity to fill that leftover 3 pounds. And we found out that B has the best value. So we are going to do our original B plus B, and that is going to be $8 plus $8, and that equals $16. And then C at 4 pounds means we have 2 pounds left over on our 6-pound sack. And the optimal capacity for 2 pounds is A plus A at $4. So we do our original C plus A, and that equals A plus A is $4 plus $11 is $15. We're looking for the highest value, and that is B plus B at $16. And notice these two are the same, and that's just because they're A plus C, just out of order. So we go ahead and write B plus B at $16. And we can move on to our next one, which is 7. Starting with A. 1 pound out of our 7-pound capacity means we have 6 pounds left over. So we look at our 6-pound optimum, which we just found out is B plus B. So we do our original A plus B, and B plus B is $16. A is $2, so that means this combination is valued at $18. After A, we look at B. B weighs 3 pounds, and we are filling out 7 pounds. So that means we have 4 pounds left to fill. So we go to our list. We look at the 4-pound optimal 4-pound capacity, which we found is C, worth $11. So we do B plus C equals 11 plus 8, which is $19. And finally, we look at C, which is 4 pounds. If we fill our 7-pound capacity sack with 4 pounds, we have 3 pounds left over. So we look at optimal capacity 3, and that is B, worth $8. So we do original C plus B, and that is $8 plus $11, which is $19. And we're looking for the highest value, which is these two right here. And they are both worth 19, and that's because they are both B plus C, just in different orders, which we've seen many times, so it won't throw us off. And so we can just go ahead and write B plus C and $19. We are moving right along. We only have a few more left to do. So we are on number 8, starting with A. A is 1 pound. So if we fill 1 out of our 8 pounds, that means we have 7 pounds left. And we just found out what the optimal capacity is for 7 pounds right here, and that is B plus C at $19. So we do original A plus B plus C, and that is equal to B plus C, we know is 19. A is 2, so that is equal to $21. After A, we look at B. B weighs 3 pounds. So if we fill 3 out of our 8 pounds, that means we have 5 pounds left over. And we look at optimal 5, which is A plus C, which is $13. So we do our original B plus A plus C. And A plus C is $13. B is $8. Adding those together, we get $21. And finally, we look at C, which is 4 out of our 8 pounds. So we have 4 pounds left over. And so we look at what is optimal for 4 pounds, and that is just C by itself, which is worth $11. So we do our original C plus C, and that is 11 plus 11, and that is $22. So we are looking for the highest value because that is the optimal combination. Because we're filling our capacity to the highest we can at the most value. So this one has the highest value. These two are the same, and that's just because they are the same combination, just in different orders. But it doesn't matter because we want this guy. So the optimal combination for 8 is C plus C at $22. We are almost there. Thank you for bearing with me. All right, number 9. We start with A. A weighs 1 pound, so we're filling 1 out of our 9 pounds, and we have 8 pounds left to fill. So we look at what we just did before. 8 pounds, the optimal combination of things to fill 8 pounds and get the highest value is C plus C, that is worth $22. So we do original A plus C equals, C plus C is $22, A is $2, so we have $24. Moving on to B, that weighs 3 pounds. If we fill 3 out of our 9 pound capacity, we have 6 pounds left. And we go ahead and look at our chart for how to fill that leftover 6 pounds the most efficiently, and that would be B plus B at $16. So we're doing original B, and that is going to be B plus B is 16 plus 8 is 24. And then we finally look at C, which weighs 4 pounds. If we fill 4 out of our 9 pound capacity, we have 5 pounds left over. And to fill that most effectively, we will look at our chart because we found that the best way to fill 5 pounds is to use A and C at $13. So we do original C plus A plus C, and that is going to be 13 plus 11 is $24. So we have a 3-way tie for best value, and that means we can pick any of these, ACC, BBB, CAC, and really ACC and CAC are the same because they're just out of order, same letters out of order. I'm going to pick BBB just for fun, because I like that they're all the same. So let's do B plus B plus B at $24. Remember, you could have picked any of them because they're all the same. All give you the same value. And we are on to filling our original knapsack capacity, 10 pounds. So this is the last one we have to do. And then we will have our final answer. So I hope you're ready for this. It's pretty exciting. All right, we start with A. A is 1 pound. So we're filling 1 out of our 10 pounds. And we have 9 pounds left over to fill. And we just figured out the best way to fill 9 pounds is to use B plus B plus B at $24. So we do our original A plus B plus B plus B. And B plus B plus B is $24. A is $2. So we have $26. Next up, B. Remember, going in alphabetical order, easier to keep track. B weighs 3 pounds, so we're filling 3 out of our 10 pounds, and we have 7 pounds left to fill. So we can go over to our chart to look at what the best way to fill 7 pounds is, and that is B plus C, which is $19. So we do original B plus C. B plus C is 19 plus B, which is 8, is $27. And finally, we have C, which weighs 4 pounds. If we fill 4 out of our 10-pound capacity, we have 6 pounds left to fill. And we know the best way to fill that 6 pounds is to use B plus B, which is 16. So we do original C plus B, and B plus B is $16. C is $11, and together that makes $27. So we're looking for the highest value, and that would be these two right here. And as you can see, they are the same exact thing, just in different order. So it doesn't matter which one we pick. Let's just go ahead and write B plus C at $27. So we did all of that work to find that this was the best combination. And you might be asking, why did we have to go through all of that? And the reason is every single step relied on the step before it. A is only worth 1 pound, right? So if you subtract that 1 pound from whatever one we're on, like let's say we were at 7 again, if you subtract 1 pound, we have to use the 6 pound to figure out what the optimal combination is. Every one relies on the one before it, or multiple ones before it, because B, we have to go back 3 steps. So like if we were at 7, we'd have to go to 6 for 1, and then at 3 pounds, we would have to go back to 4. So it may seem long, but this is actually like the fastest way to do it. So that way you're not wasting time doing random combinations and probably redoing ones you've already done, because remember, we saw a lot that were like these two are the same. But having it organized in this way and going through it using an algorithm methodically, this actually saves you a lot of time. So we could keep going. We could use 10 to figure out what the best capacity would be for 11. And we could use 11 to figure out 12, which is the neat thing about this. The opportunities are endless, which is pretty neat. But, yep, we found out to fill our 10-pound knapsack with these 3 items, the best way to do it would be adding 2 B's and a C, and that would give us $27 value. So thank you so much for listening to me and for hearing every single step, and I had a great time. I hope you learned something new. I hope you have a great rest of your day, and I will see you next time.